real quick here. Hello. They'll come when they're ready. Before we actually get really into it, I'm kind of curious, like, how many people are completely new to Rack? Like, I'm not really even, okay, a few hands. On the flip side of the spectrum, how many people have experience using Rack in, like, real projects? Oh, that's actually way more than I expected. Okay. Well, for everyone who's new to the framework, I'll just give like a real quick overview, because maybe, I don't know, it would be helpful. Reactive Cocoa is just a really handy way to model a lot of different things in programs today. Like, things happen, you want to react to them and do stuff. It's just like streams representing absolutely anything. So it can represent network operations, it can represent UI events, database reads, file reads. It's literally the paradigm to end all paradigms. But more seriously, it's just, you know, it's a way to think about your program in terms of inputs and outputs. So your inputs might be user input, it could be network input, file, etc. And then the output is what you display to the user or what you save to disk and stuff like that. And so the stream-based model gives you a really handy conceptual guide for, like, you know, you're constructing a stream that is literally your inputs come in and your outputs go out. And you can model a whole bunch of different things that way. That's super powerful. And so that's why we like it so much, and that's why, you know, when we have third-party APIs, we really want to bring them up into that world and use them in the same way and compose them all together. But anyway, so during this talk, this will hopefully not require too much knowledge of how Rack works today. I'm instead going to talk more about how I think it should work in the future, which it'd probably be a little different for anyone that's been using it so far. But feel free to interrupt me at any time during this talk. Like, if you have questions about what I'm saying, or if you feel like, you know, there's a point at which you stopped understanding what I was saying. Although general Rack questions, we'll still have the Q&A panel later, and you can feel free to ask that stuff there, and we'll go into lots of detail and go back and forth about it. But yeah, point being, interrupt me. I'll, yeah, answer your questions on stage. All right, so the future of Reactive Cocoa. This has nothing to do with Swift. So my talk was originally going to be about what's changed or what's been changing in Rack 3.0. And as I was working on that talk, I went to Microsoft's free Lang.next conference last week. And Eric Meyer, who is the creator of reactive extensions for .NET and also influential in the development of the Haskell programming language, gave a talk about duals and about RX and kind of his idea of where RX should go. And that really gave me a lot of crazy ideas. And so now this talk is more like, oh crap, let's hit the emergency brake. Let's kind of reboot Rack 3.0, because I think a lot of the stuff he was saying makes a whole lot of sense and really solves the problems we were trying to solve, but in a much better way. So we still have a chance to do things right before we release a major version, another major version. The central theme of Rack 3.0, which it's already had, is simplicity. It's like, you know, this is a really complex framework, and we want to try to cut out concepts that are confusing or duplicative or, you know, just generally hard to understand. So far it's just been like 90% deleting APIs, which honestly I think is an amazing way to develop, and I wish more things did that. But so it'll still be about simplicity. It's just, I think what Eric was talking about is much simpler than what we had. Excuse me. If you've seen documentation about Rack or kind of got into the nitty-gritty a little bit, you might have run into these terms, hot and cold. In my opinion, this is the most confusing thing about Reactive Cocoa and reactive extensions today. It's like, what is a hot signal? What is a cold signal? What is lukewarm? What do all these things mean? Basically, a hot signal is something that's always alive. So it's like, you know, you have a button that you're tapping in the UI. That stream of events is always active. It's always notifying you. It's like, when the user does something, it's pushed out to you. The cold signals are more like deferred work, kind of like promises or futures. So it's like a network request might be a cold signal. And when you subscribe to it, then it shoots off a network request, starts doing work, and eventually comes back to you. And if I've lost you already, this is exactly why it's super confusing and why I think we need to change it. So Rack 3.0 solved this problem by encouraging cold signals everywhere. So it's like creating this expectation that whenever you subscribe to a signal, stuff is going to happen. But this makes things a little complicated because it's like, why should the word subscribe imply that side effects are going to happen? Why should subscribe kick off a network request? Doesn't make much sense. And it's also a lie. Like the example I used of the button taps earlier, that's always going to be a hot signal even if we change our APIs. Like there's no way in which subscribing to the button causes the user input to happen. Like the user input's always happening, and it's just whether you care about it or not. So point being, I think this is a distinction that does need to exist. We just need to figure out a better way to codify it or represent it. So .NET and reactive extensions offer these 4 interfaces. In .NET, they really like using I to mean interface because it's fun. Because com, apparently. So these correspond to pull-driven and push-driven streams. So an enumerable and enumerator, that's what you use when you're like reading from disk. It's like you're pulling data, you're like, whoa, I'm ready for the next chunk, I'm ready for the next chunk. Observable and observable are like the button example that I used. It's like, you know, you're observing the user input that is going to be happening whether you want it to or not. So observables are the most similar to what we call signals in Rack today. They have those methods for like subscription and stuff that I was talking about. That's where you embed side effects, and it's like, oh, you know, when I'm ready for this network request to start, I'll subscribe to it and stuff will happen. That's the class, or excuse me, the interface you'd use in .NET as well. But so going back to Eric Meyer, so his talk focused on how these types relate to one another. Specifically, they're known as duals. And I'll get into a bit of what that means in a second, but basically there's a really tight relationship between these types. And so I'm going to continue to use the .NET terminology because I think it really has good parallels. It's like, oh, enumerable and observable. Yeah, those can be 2 sides of the same coin. But anyways, these are just names, and we can always change these. But I'll explain a bit more about what this means. So this is the most basic type, the one that you should be pretty familiar with today if you've used Rack. An observer or subscriber in Rack terminology, Reactive Cocoa terminology, performs side effects whenever an event is sent. This is a Haskell or now Swift type signature, indicating that this is like, you can think of it like a function that takes an event and then does stuff. The empty parentheses represent stuff happening. But so basically, observers or subscribers, you push them events. Oops, sorry, excuse me. Get too excited and very handsy. But you push them events, and stuff happens. There's also a type in Swift known as sync, which represents the same thing. But then, you know, with subscribers or with observers, then you get back observables or signals. So this is a bit more complicated, but this is saying, this is something into which you pass an observer, which is in those outer parentheses there. You pass in an observer, and then stuff happens. So this is that subscription thing I was talking about. It's like when you subscribe by attaching a subscriber, stuff happens. The network request is started, data is read from disk, what have you. Does that make sense to everyone so far? Does anyone have questions about this? Okay. So far, it shouldn't be too complicated. Maybe the type signatures are a little confusing, but you know, it's pretty easy to see. You've got this observer type, and then put more parentheses, and then it does stuff when you pass in observers. So what's a dual? A dual is when you flip around those arrows in the type signature. So in this case, instead of event to empty parentheses, it'd be parentheses to event. Like that. Does that make sense so far? This is the dual of the observer type. So this is something that, when invoked, it returns an event. So you can think of this like a function that takes no arguments, and then it gives you an event. We know this by another name already. That's an enumerator, right? Or an iterator, or a generator, whatever you want to call it. This is a concept that, as computer programmers, we're all fairly familiar with. You ask it for something, and it gives you something. And you just kind of keep doing that until it's exhausted. An enumerator returns, in this case, events when evaluated. There's also parallel to observable. So this is enumerable. So you're saying, when you invoke this thing, it then gives you an enumerator, which you can evaluate fully. And so the corollary to this is, if you have an enumerable, you can pull out any number of enumerators from it, and then each of those can be iterated independently. More concretely, enumerable could be used for like arrays or dictionaries. Like, you can think of those as matching this type. It's like when you pull out object enumerator on NSArray, you have the NSArray as the enumerable, and then obviously the enumerator is this type I was showing you before, where you do next object, next object, next object, and eventually it's done. So altogether, these are the type signatures we have. And the reason I was using these type signatures is because I think it makes it really easy now to see the parallels and the symmetry that I've been talking about. You have push-driven streams on top, where it's you pass in an event and stuff happens. And then you have pull-driven streams on the bottom, where you ask for something and you get back values. Does that all make sense? Pretty cool, right? Like, yeah, symmetry, amazing. But there's one problem with this. Enumeration is blocking. And one of the core conceits of Reactive Cocoa is that your app should be responsive, it should react to things. There should be a big focus on asynchrony and concurrency and just generally being responsive to the user. So looking back at that type signature, you can kind of see why this is blocking or synchronous. It's like, in order for this to even return, it has to have an event ready. It has to have the thing ready to go. So it's like if you're reading from a file, it needs to have that data before it can return control to you. So you've blocked the thread until that happens. That sucks. Don't block threads. So if we wanted to avoid that problem, we can instead retrieve values asynchronously. The most easy or perhaps intuitive way to do this is to put each event into a promise. And a promise is just, it's a way of saying that this value will be delivered to you at some point in the future. So this single value, and that's all you're going to get. And you'll kick it off, and eventually it'll come back to you. So for now, using this new pull-based interface, you can say stuff like, oh, give me a promise representing the next chunk in the file. And only when I'm ready to actually do the file read will I start this. Or it's like, oh, I'll start this file reading on a background thread, and when it's done in the background, then I can do something interesting with it. That way you're not blocking the UI, you're not blocking a thread, you're not getting 1-star reviews on the App Store. It benefits responsiveness. It kind of breaks the duality thing I was talking about before, but it's worth it. These promises are important because they allow work to be performed out of order and asynchronously. It's not just about not blocking the UI. Like if we just want to avoid blocking, we can use rack signal or observable as it exists today and just push things downstreams and then respond to them at the point of call. But promises offer a few other benefits in this case. They allow the consumer to skip work or do work out of order. So it's like, going back to this enumerator, because a promise is returned instantaneously, the caller can have an enumerator, it can go through it like 5 times, it pulls out 5 promises. No work has actually been performed at this point, but it's like these represent 5 chunks of the file that could be delivered at some point in the future. And then it's like, oh, if the caller realizes, oh crap, I committed to too much work, I don't actually want all 5 chunks, I just want the 5th chunk, can get rid of the first 4 and only start the 5th. Thereby avoiding unnecessary work. Or it can evaluate them out of order. It can evaluate the 3rd chunk, then the 2nd chunk, then the 4th chunk. Because in a file, you can always jump the pointer around and get the data that you actually want at that point in time. So it's a really powerful way to let the consumer drive the behavior that you care about, like the reading from the file or the reading from the network or whatever it may be. Does anyone have any questions about that so far? Spoiler alert. Okay. I'm not going to tell you what a monad is. Don't ask. more seriously, like when you have these definitions, observables and enumerables are powerful abstractions for streams and asynchrony. Your observable is still this good abstraction for, oh, you know, something's always happening and I decide whether to listen or not. And then you have enumerables, which are like, oh, I'm ready for new data. I'm ready for work to happen. I want to kick off network requests, stuff like that. And the observer and enumerator interfaces are also beneficial because you can create different concrete implementations that change their behavior. So like a particular observer could decide to, you know, handle events concurrently. A different one might require that they be handled serially, stuff like that. But to recap, observables are things driven by the producer. So the button on screen, it is driving the observable, the stream of events, because the user input is always going to happen whether you want it to or not. It's a stream that the consumer doesn't really have any control over. They can decide not to listen, but that's not control. That's not saying, oh, I determined when these events are going to happen. No, they're going to happen. Enumerables, by contrast, are controlled by the consumer. So it's the consumer deciding when to read from the file, how much to read, how quickly to read, whether to read concurrently, so on and so forth. This leads to some interesting properties as well. So observables are then the same for all observers. You know, again, the button example, which I'm going to beat to death here. If they're the same to all observers, it means that the user input is getting distributed to all interested parties simultaneously, or basically simultaneously. There's no difference in the order that they receive events. There's no difference in the timing. It's just like it happens, and then everyone gets notified right away. Enumerables are independent. You can create independent enumerators that do work at different times, different order. Like you can have different enumerators that are at different points in the enumeration. So like let's say you create two enumerators into the same file. You can think of that as two file handles that each have their own position within the file, and you can go through them at the pace that you want. So even though these types have this kind of symmetry that I was talking about before, they're very different in usage, and they each map very nicely to a specific use case versus the other one. Another way to say the same thing, observables are always alive, always happening, and enumerables let you start new work, like opening a file handle with each enumeration. And if you've used Reactive Cocoa and gotten into the terminology, to not give away spoilers, this may be starting to sound familiar. The reason I'm giving this talk, the reason I'm coming back around to this is because this terminology, this hot and cold terminology I gave before, we can actually represent these things with real types that have the behaviors and the properties that we want. Instead of hot signals, which are this vague, kind of ill-defined and confusing concept, we have observables, which are things that are always alive, always pushing you events. And instead of cold signals, which trigger side effects upon subscription, we have enumerables, which trigger side effects when you request values. And so by separating out this single kind of mammoth rack signal type into these two different types, observable and enumerable, it becomes really clear what your intent is with an API. So it's like in a networking API, you might return an enumerable, which is like, oh, when you enumerate, it fetches each successive page of results from the API. Or in a UI context, your button might return an observable of its events. So even though we've taken this one rack signal type and it ended up with two different types, we've actually improved, we've made things simpler. Because complexity is the result of combining concepts in a confusing way or intertwining concerns in a confusing way. And now we have two different types that have two very distinct and different purposes. You can even convert between them if you want. But we've eliminated the confusion where it's like, oh, I have a rack signal. But what does that mean? When does work happen? How many times does work happen? Now it's very clear in the type. So simpler. Does anyone have any questions about this? To me, this is kind of like, this is almost a sales pitch to you guys. I want to know how you guys feel about this because I would love to have this in Reactive Cocoa 3.0. I think this is the biggest win we can have in simplicity and maybe even understandability. And I really wanted to see how it feels to you guys. Yes, Rob. Oh, sorry. Do we have a mic still?
So this is highly reminiscent to me of iteratees. Is that a valid observation, or is that sort of me mistaking this?
Is that a what observation? Sorry.
A valid observation.
Yeah, I mean this concept exists in many languages, many platforms. Basically, iterators, enumerators, generators, they're all words for the same thing, which is like something that you pull from and stuff happens. I think the big unique insight that we had here is that instead of blocking the caller with the evaluation and the work you're performing, you should be returning promises that will later do the work. That way the caller can have full control over when stuff happens and how much stuff happens. So even though it's very similar to like enumerators and iterators you may be familiar with, I think it still kind of has its own nice Reactive Cocoa asynchronous spin on it.
Thank you.
Yep.
You may just sort of repeat this to save them running that.
Okay.
Rack sequence is always like the
Thank you.
step
Yes.
child. What happens with it? Where does it go? Does it disappear? Does the enumerator replace it properly?
So Danny asked if, so in Reactive Cocoa 2.0, we have this rack sequence type that is a poll-driven stream. But it's more like this poll-driven stream, which is the synchronous one. So rack sequence, as it exists today, would not be sufficient for this. It was kind of ill-conceived. It's more like something you can evaluate, and then once evaluated, it's always done. And it was, I don't know, it fit really badly into the framework, and most people were confused about why sequences and signals weren't interchangeable. I think making this about the side effects and about the asynchrony makes the distinction much more clear. And so I would be in favor of burning rack sequence to the ground and replacing it with something more like this, which is an enumerator that gives you produces values asynchronously. Did that answer your question?
Yeah, although at the end there you confused me a little bit because you almost make it sound like there would be an additional thing on top of these two concepts to replace rack sequence.
No, sorry, there will be
just those two.
Yep.
Yeah,
just
that
these.
makes more sense.
Yep. Yeah. Sorry. The microphone situation is constantly changing. I need to react to it.
Can you restore the duality by putting promises in the push streams as well?
That is an excellent question. So what Uri is asking is whether promises can somehow go into the push signature to make these duals again. Unfortunately, if you look at it and kind of think about it, it doesn't actually work that well, because that would mean that you're pushing promises in and then work is happening immediately, which is not really what we're trying to describe, right? So you wouldn't ever want to send promises to an observer, in my opinion. I think that doesn't make a whole lot of sense. One possible thing you could do is you can make the side effects, the empty parentheses at the end there, you could put promises on those. So it's like you send an event to an observer, and at some point later, it'll do the side effects and tell you about them. I think this is not as useful. Eric actually proposed something similar in his talk, but I don't think it offers that much utility. The primary usage would be like if your producer, like your file reader, wanted to know once the consumer has completely handled the event, and then can do something at that point. But I don't think that's that useful because push-driven streams should be producer-driven. Does that answer your question? No. Anyone else? And again, if there were slides you got stuck on, or if I lost you somewhere in the middle there, please ask, and I'm happy to explain more. Yep. Sorry. Can we run the mic over here?
So some of this terminology is already in use in places, like you said, like reactive extensions. Do you think Rack 3.0 would lean towards that?
So Josh Abernathy will kill me if I say yes to that question. We are not super interested in using the same terminology as reactive extensions, not to like be religious about it or to avoid it specifically, but just because we think there are terms that are more natural in Cocoa. So I wanted to use their terminology here, excuse me, simply because I think it shows you the parallels in the names before we even dive into the types. But if we were to actually implement these today, they would probably go by different names. I actually, in the presenter's notes for this, which you'll see once I post them. I looked through the Swift APIs for similar interfaces, and some exist, but they go by completely disparate names. So it's like observer is sync, enumerator is generator, enumerable is sequence. And so there are all these established names in Swift already. And so it's like, if we start building a new API that uses Swift, maybe we'll go with those terms and stick, be consistent with those. Yeah. Anyone else? Sorry, Dave. Audience participation, yeah. Exercise.
Not really a question, but maybe just ask you to comment, I guess, on how you compose the push and pull. So, for example, if I have a generator and I get a promise, that promise might do a whole bunch of, like there could be a tree of, it could be calling to some other generator with other promises. So I don't know how you, because right now everything's signals and signal operators. So I'm not sure how you sort of jump back and forth between something that's pulling and something that's pushing, and how you compose them all sort of in one big unified.
Sure, yeah. That's a great question. And my response to that would be, we have to deal with this problem already today. It's just not as explicit. It's like when you think about operators like replay, that changes a cold signal into a hot signal, but the effect is completely lost in the type system. It's like you have no idea that that happened further down the line. And you still have to be very explicit about it. You're like, oh, I want it to be evaluated this way. You're saying like, in this case, I want to kick off this cold signal, do all these things, and then collect the results, and it'll just be evaluated at once, and I'll always have the results in the future. So point being, you have to be very explicit about it already. I think this would help because it gives us a way to describe more concretely how those changes occur. So like a pull-based stream here, the interface for this would actually look more like you decide you want to evaluate the whole stream, and then send all those events to an observer. That would be the method. It would be like, start evaluating and forward all events to this observer over here. For the push-based stream, you would do something more like replay today, which is like, I want to start collecting all the events from this point forward, and then someone can enumerate over them later. And so in this way, each of these stream types can return or interact with things from the other type, but it's very clear at what point that happens and how that evaluation occurs, which is something that I think is lost in our type system and our API today. Does that answer your question?
Yeah, thank you.
You sure?
Well, we'll see where things go, I guess, right? Can't answer everything here, but
yeah. All right.
Yeah.
Yep.
So you mentioned Swift had some existing names for some of these things already.
Panel discussion.
Okay.
Sorry.
So where do rack commands fit into all this? That
is a great question. So rack command is possibly the worst API I've ever built 5 times in a row. It's really hard to fit into this world in general. My intuition, I haven't actually tried to do this, but my intuition is that by representing things in this way, we'll actually come up with more natural ways to describe UI actions that occur and what we want to do with them. Because I think rack command is trying to paper over a lot of the hot, cold confusion. I don't know. I haven't investigated, but my instinct is that I feel like we can get rid of it and replace it with more sensible APIs based on these types. Yeah.
So what about, so you have push streams that are producer-driven, pull streams that are consumer-driven. What about streams where producers and consumers have to collaborate on the way
that's a
things
good question.
get evaluated?
I mean, so again, this is one of those things where I haven't played around too much, but I think, excuse me, these streams are still just values themselves. So there's nothing to stop you from sending a push stream along a pull stream or vice versa. And I think that's how you would get the combination of both effects. But again, it's something I'd have to play with and really see how it feels. Yep. Oh, sorry.
Isn't the promise itself actually kind of a push stream?
It is, but it's a push stream that clarifies its intention very well, I think. It indicates that you'll get exactly one value. There's no possible like error state or any complexity like that. It's just at some point in the future you'll get a value. You can kick it off on a background thread. It's more like a block where the result is cached. It's not really stream-based at all. It's just like a stream of one. So it's more like, you know, a block you put into a queue, and eventually it comes up with a result, and then that result is hanging around until you're ready to retrieve it.
But if you use like the same interface, that would also solve how you connect the two, right?
Not fully sure I understand that question, but it's kind of like streams are a more natural fit anytime you want to represent things that recur or can occur in chunks. So it's like, you mentioned that a promise is a push-based stream, but for the UI button example, that won't work. Like that's something that needs to fire multiple times every time the user taps in the interface. And this is why we really believe in streams over promises as an abstraction to like, you know, describe all these recurring events and describe the full lifetime of your program rather than just some work you're throwing onto a background thread and getting back later. So for I believe that promises are useful in this narrow case of, you know, telling you that there's one value that you're going to get, but I don't believe they're really much more extensible or composable beyond that.
One more, Justin.
Okay, one more question. Yeah.
If I recall correctly, there was some work to remove the rack stream class entirely and replace it with rack signal. So how's that going to work with these two things?
So if we decide to go down this road, rack stream would continue to exist, and it would be the new superclass for the promise-based enumerator. Because there are still operations that are common to both these streams. Like you can map over all the things that these both return. You know, when UI button presses happen, you can map that to the time of day. When you're reading from a file, you could also map that to, you know, like you can map the data chunks to strings. There are a lot of operations that are common to both, and we want to share the implementation so they would have a super type. All right, I think we have to break for lunch.
Yes.
So
if you still had questions, yeah, he doesn't get a round of applause. If you said, no, I said he doesn't. That's quite enough. If you still have questions for this talk, don't worry, we'll come back to this stuff in the panel discussion, and there'll still be room for questions. So lunch arrived precisely on time at half an hour early. So we should get to that. After lunch, we're going to do John Stanley's talk, and then we're going to have this famous panel discussion, which will happen for all your questions. And we can mark the day that Justin came so close to complimenting promises. All right, let's have lunch.